So, maximal item set cardinality as you can see is the minimum, and then closed frequent item set is the superset of the maximal frequent item set, and similarly the frequent item set is the superset of the maximal frequent item set and the closed frequent item set. Now, different way we can represent the database, because we have to access the database many times. So, therefore, representation makes difference. So, one way representation, traditional way is like horizontal way, where you can see the transaction is in each row and items are like A, B, C, A, B, E. Other way is representation is something called the vertical data layout. So, you write the item on the column and then each item appears in many transactions, you note down those transactions. Suppose A appear in the transaction number 1 and then A appear on the transaction number 4, 5, 6, 7, 8, 9. So, these are the number of the transaction. So, quickly you can count what is this cardinality and so on. No need to search again the each transaction here. So, you can find easily the number of times that item occurred. Okay. So, 1, 2, 3, 4, 5, 6, 7. So, this is like 7 times. So, this is the way, and then today what we look into a different algorithm, something called is the Pregrowth algorithm. So, this algorithm has two parts. One is how to represent the data in a much better way, and once we represented the data, then we will find the association rule, and before the association rule we will find the frequent item set, because finding association rule is much easier once you find the frequent item set, as we have seen, or if we find the closed item set or maximal item set, we can find the rule. So, therefore, today we will focus on how to represent the database in a much compressed way, compressed representation. So, that is something called is the FP tree, frequent pattern tree. So, this portion we will focus today. So, here we go. Let us say we have the transaction on the left side. Okay. So, we have the transaction as you can see. So, this is the transaction database. So, it is horizontal representation as you can see. So, at transaction, first transaction there are 2 items, second transaction there are 3 items, third transaction there are 4 items and so on. So, what you have to do? We have to represent this database in much compact representation using tree, and final tree will be like this one. So, now what we do first? We have to find the count for each item. So, you start counting what will be the cardinality item A, this is 1, this is 2, 3, 4, 5, 6, 7. So, cardinality of A is 7. Then what is B? B is 1, 2, 3, 4, 5, 6, 7, 8. So, B is 8, and what is A? 1, 2, 3, 4, 5, 6, 7, right. Then C is B is 1, 2, 3, 4, 5, 6, 7, 8. So, what is C? C is 1, 2, 3, 4, 5, 6, 7. Then D is 1, 2, 3, 4, 5. Then E is 1, 2, 3. So, A is 3. Now, you sort this item. So, then B will come first, then A or C, let we put A C, and then D and E. So, this is the sorting order. Now, what you do it? This transaction you arrange based on the sorting order. So, if I arrange it here, so So, now first transaction I can write it as actually B A. Okay. Second transaction I should write B C D. So, this is B C D. Third transaction I should write B is not here, then A C D E. So, it is the right way. So, this is right way. Then A D E, this is also okay. So, this should be B A C, B A C, and then this is B A C D, then this is B C, this is okay, then this should be B A C, this should be B A D, this is okay. So, what did I do? First you have to find the cardinality of each item, okay, and then based on that you arrange the each transaction. So, second step. Now, you have to generate the frequent pattern tree. How will generate? So, first you have to traverse the each transaction and then you add this information to the tree, already generated tree. Let us say and incrementally do it. First is this is null, this is root. Now, this is transaction is first B and A. So, then you make a root B and then A. This seems to be wrong. Okay. So, then what you have to do it? So, B along with you write the support of B. Support of B means at that moment. Support of B means how many B? It is only one transaction. So, B is 1 and A is 1. Next you go to the second transaction, that is B C D. So, B is already common. So, you have to take the same path B and cardinality will change. So, cardinality will change, cardinality will be 1 plus 1. So, it will be 2. B then C, C is you should have a different path C and then D, C is 1 and let us say we put D here, D is 1. Are you getting? Then what next? A C D E. What is A? A is there is no starting A. So, you have to start the new branch. So, this is A, then C D E. C is A, then C, let us say C and D. So, initial when you start from the root, if there is a common you make them common, but later on you cannot add. So, it is a tree, we are saying it tree, we cannot add this C with C. Then what next? So, this cardinality is 1, this cardinality is again 1, this cardinality is 1, A C D E, let us say E is here. Next A D E, A is here, D is not here. So, you have to make a different branch D. Let us say you can make it okay, A D E, A D E. So, let us say here E. Next is B A C. So, starting is B, then A and then C. C is 1, but this will be incremented to this will be 3. Then is B A C D. So, this is B, this is A, this is C and let us say this is D. So, this is 1, this will be 2, this will be 3, this will be 4. Then B C. So, B is here, then what is C? C is no immediate C, yeah, B C. So, this will be 5, this will be 2, that is all. Then B A C, B is here, A is there, C is there. So, just you it is there already there is a path. So, you increment the value. So, this will be 4, and this will be 6. Then B A D. So, B is here, A is here, D is not there. So, then B A, then you have a path here, let us say this is D. So, and you have to increment, this will be 5 and this will be 7. Then B C E, this is B, then C is not there, right. So, then B C, and then you have to find a path, let us say this is the path, this is E, and this will be incremented 3 and this will be 8. Now, you check out each item cardinality. So, B was 8, A should be 7. So, A is 5, this is 6, where is A, one more A, this should be 6. Okay, this one, this should be 2, okay. So, this is 7. Then C was 3, 3, 6, this was also 7, this is 1, 7. Then D is 1, 2, 3, 4, 5. So, D is 5, and E is, this is 1, 2, 3. So, E is 3. So, you can generate the tree easily. So, once you generate the tree, then you can find the frequent pattern. Once you find the frequent pattern, you can generate the rule. Okay. So, we learned the frequent generating the FP tree, but learning or say mining the frequent pattern is bit complex with compared to this much easier representation. So, that is deferred to the next class, okay, because it will take little time. So, this entire thing we learn the generation of FP tree. Now, we will know the how to generate the frequent tree. So, that will be deferred to the next class. Now, what we will do the next we will know how to evaluate the association rule. So, we got this tree, right. So, extra thing is there, we will have the header table, and header table consists of the item set. Item set means item set here A, B, C, D, E. So, obviously, A will not come, A is like B will come first, because cardinality of B is highest, then A, then C, then D and E. Now, there will be a pointer, wherever A is there, it will connect to that pointer. Let us say here, so it was A actually. So, this will connect A, okay, and this A will connect to the somewhere else if A is there. Similarly, this was B. So, B will be connect to the first B, and this B is connected here, but this is a threaded tree. Okay. So, let us say this is actual link and this is another link here. Okay. So, that is why it is written in a threaded way to distinguish which one is the tree link and this is the link to the item to item. So, there should be a link. Similarly, C will be linked to the first node and then each C will be linked here, this one. So, if you add it 3 plus 4, 4 plus 3, so 7. So, cardinality you will get easily. Similarly, D will be connected here and then here. So, now if you want to find what are the item set started with D or ending with D. So, similarly, what you can do D, you can go D and then if you only find this path from here, you only find this path here and you only find this path and here, no need to search the any other path. So, because when actually you generate the data FP tree for the big data set, so the tree will be very complex. Now, if I want to find the frequent item set with let us say D, So, D and its superset. Then what I should ideally do? I should go to the D wherever D is ending, and then I search only those path. So, let us say E, I will search E means here, I will go from here to here, and then I will search here and so on, that we will discuss in the next. To evaluate the rule. So, association rule algorithm can produce a large number of rules. So, but all rules are not very interesting. So, we have to find the interesting rule, and as we know that for measuring the interestingness of a rule, what we do it? We find the confidence of the rule, but support confidence framework sometimes it mislead the rule. Okay. Say which one we say is confidence is high. So, that sometimes it mislead the rule, that is we will see next with one example. And to find the interestingness, so we have to go very systematic way. So, we like in classification we have the confusion table, confusion matrix. So, here we will have the contingency table. What contingency table does? Say suppose we have the rule x to y, as you know the x, we are finding the co-occurrence of x and y. Whenever x occur, so y very likely it will occur. So, that is we need to find the this rule interestingness. So, how much this rule will help for say let us say in marketing or any other purpose. So, therefore, we have to find the contingency table. What is contingency table? So, we have the rule x to y. So, you write x here and not x. In the same way we did in the classification task. Similarly, y and not y. And now, this is the entry, it indicates number of support when x and y occur together. So, F11 is the support of x and y, and F10 is support of x and not y. That means, it is present of x, but y is not there. How many times that is the case? So, that is something called F10, and then there is something called F01. What is F01? Support of x and not support of x naught and y. That means, x is not there, only support, only y is there. So, this side is only x, this side is together x and y, this side is only y, but not x, and this side is x and y both are not there. So, this indicate it is how many total number of x in the data set. These indicates how many number of y appears in the data set, that means support of y, and this indicates together x and y, and then both are this one is both are absent, and is the total number of transaction, total number of items that appear in how many times, that is it all together is n. So, these contingency table will be used for finding the interestingness. So, here we go. Suppose one example here. So, from the transaction data set we got this information tea and not tea, similarly coffee and not having coffee or not drinking coffee. So, this side is like people like tea, and we counted how many time the tea was purchased. Okay. So, that is 20, and how many time coffee was drunk or purchased is say 90 times, and total is 100. So, now if you have a rule that is T, so we find the confidence. What will be the confidence of this rule? What confidence? What is the formula for the confidence? What is the together tea and coffee appears how many times? So, this is 15 divided by 20. So, this is we go. So, this is confidence we will get it the 0.75. So, 75 confidence for a rule is quite good. So, basically this is a good interesting rule. That means, it says the people who have the tea very likely they will have the coffee 75% time. Now, we will see is you just neglect that whether the people is having tea or not. People having only coffee is 90%. So, because this is the total number of coffee people having is 90. So, therefore, probability of coffee is 0.9, 90%. What we want to find? Togetherness of the, whenever people purchase X, he or she will purchase also Y, but Y itself is 90%, but if we put with X, it is decreasing. So, that means that such rule is actually, it may happen, but such rule is kind of misleading. What do you want? Actually, that item X, whenever item X will appear, it should appear with Y, but we say is, if we sell the Y itself, that is 90%, but if we find the rules, that is X and Y appearing is much lesser than the individual Y. So, this type of rule may appear, but this type of rule is like a kind of misleading, because if I say, if we sell only Y, we are getting 90% times, but if we say is okay, if you sell X with Y, so that will reduce. So, from the business tactics, so this is not a very interesting one. So, therefore, this rule is not, this measure, because of the problem with the measurement of the confidence, because we are only taking the confidence, and the formula in the confidence we are not taking, considering the support of the right side item set. So, therefore, we should have some other kind of measure where it should consider the support on the right side item set. So, here we go. So, confidence X and Y should be sufficiently high to ensure that the people who buy X will more likely buy Y than not buying Y. So, confidence of X and Y should be greater than the support of Y. We are not considering the support of Y, because the formula says it is altogether X and Y divided by the only support of X. So, we should consider this part also. And what do you want? That confidence of X to Y should be greater than the support of Y. So, if we assume we should consider the support of Y, now we will come up with a new measures. What is the criteria? Criteria should be this one, confidence of X to Y of this rule should be greater than equal to support of Y. For the simplicity, we consider is, we want that confidence should be as same as the support of Y. For simplicity, we consider this is equal. Earlier I said it should be greater than, right. So, now we say is it should be equal. So, what is this? What we say is a rule X to Y. If the people purchase X, very likely they will purchase Y. So, that is in probability term, what we can say is the probability of Y when people already purchase X. And what do we want? That should be the same as from here, that is the probability term, that should be same as at least the support of Y. Support of Y, what is the support of Y? How many times Y appear in the transaction. So, that is nothing but the probability of Y. So, we can write the probability of Y, nothing wrong with that. So, we can write this one. Now, we learned probably the base theorem, right, when probability of X given Y is probability of X Y of probability of Y. So, from here what we can write? Probability of X Y equal to probability of Y into probability of X given Y. So, what is this? Probability of X given Y. Okay, I think I changed something. So, base rule says the probability of Y given X equal to. So, from here what we can write it? Probability of X Y equal to probability of X into probability of Y given X. And what is that? Probability of Y given X is P Y. So, then from here what we can write? Probability of X Y equal to probability of X into probability of Y. So, that is we read here. So, joint probability of X, when we can multiply of individual probability when they are independent. So, X and Y are independent. So, we cannot say is when X appear, Y also will appear. So, they are independent. So, this value will be greater than this value. When it will be greater than, so any one of the value will be more than the earlier value. So, then we say is the X and Y are positively correlated. If the P of X Y is greater than of this value, because this is independent case. So, if this conditional probability is greater than this value, so we will say is the positively correlated. If it is lesser than this value, so we will say it is negatively correlated, and if it is exactly the same, then we will say same is of multiplication of p x and p y is same as the p of x y, then we will say it is independent, it is nothing correlated, not positive and not negative. So, therefore, we find this is something called the lift, that is we wanted to find. What is that? That is we already explained. What is this? This rule x to y means probability of y when x already appeared. So, that is the probability of y already x appear, and then what we wanted? We should consider the support of y. So, that is the probability of y. So, this is something called the lift. And similarly, there is something related information is called the interest. So, joint probability divided by the individual probability. So, this is showing is if it is independent, this is something, if it is independent, we are dividing by the independent values, and if it is positive, if it is greater than 1, so then we say is okay, there is some correlation. If it is less than 1, so there is no not negative actually, because this is all our probability. So, it cannot be negative. So, it cannot be negative, it can be, this value can be more than 1, that is fine, but it cannot be negative, because this is also probability and individuals is also probability or negative correlation. Yes. So, if value is less than 1 means it is negatively correlated, and it is more than 1 means it is positively correlated. And why this is joint probability, and this is actually when there will be independence. So, that is the p x into p y. So, therefore, we will work with these two, lift and interest, and for the binary variable we get this type of equation here. This is like we work with the continuous value Pearson correlation we found. So, this is similar as the correlation for the binary variable. Now, we come back the example. So, what was the confidence? Confidence was 0.75 and only probability of copy was 0.9, and what is the value of lift? Now, we consider the joint probability. What was the formula for lift? It is the probability of y given x. So, that is 0.75, and support of y, support of y is nothing but the probability of y. So, that is 0.9. So, it is value is less than 1. So, it is actually negatively correlated. If the people have coffee, people have tea, so very likely they will not have the coffee. So, there are many measures, we stop at this point. So, there are many. So, lift how to compute, obviously you should know how to compute. So, this is contingency table and you compute lift from here. So, one thing you see, lift value can be more than 1, because it is divided by the, it is not the probability, but it is using probability you compute the lift. So, in this table we find the lift value is 1.11. Here you get the value, lift value is 10. So, simply you put the formula, you will get it. So, joint probability. So, this is the joint. No, this is not the joint. You have to find the probability of y given x, and then you find the lift, you will get it. So, similarly, we have the so many measures you can see here. Obviously, so maybe you can look into Z measures, Gini index, mutual information, these 3 or 4 measures frequently used, and what is that confidence here. So, here you have the interest, cosine formula you already know, Jaccard is there, Jaccard you know here, this is same way. So, especially you can look into lift, interestingness, and then what is called is cosine and so on. I stop here.